Now, in some senses, these are all one family, okay? But on your table of standard integrals, which I hope you've seen, this guy, okay? Which, by the way, probably in the next few years is going to be expanded, but that'll be after your HSC. You can see down the bottom there's a couple of extra ones, okay? And they seem pretty weird and complicated, so we're going to give them a go. Okay. Now, the way that I'll do this is by way of the kind of question we looked at before, when you have like a weird-looking integral, but they can say, look, differentiate this, I'll give you a function, differentiate it, and then hence integrate this other function that I'll give you. Okay, so let me show you what I mean. Let's try and differentiate this function. It's a bit weird. It looks like this. Log of there we go. Okay. That looks awkward, doesn't it? Right. Have some faith. It'll work out nicely in a second. What are we going to do? This is just chain rule, isn't it? Actually, it's a few versions of chain rule, but I reckon you guys can handle it in your head, right? What's going to be on the numerator? Because I'm differentiating, I'm going to get f dash on f, aren't I? Okay. So what's on the top? Let's differentiate. What do I get? 1 is the first thing. Okay, that's the derivative of x. What happens here? This is really x squared plus a squared all to the power of a half, isn't it? Okay, so we can treat it as chain rule. We'll just do our business with the powers and all that kind of thing. What should I write down first? Woo. Slow down, slow down. Let's try and do the steps one at a time. We will get there. We'll get there. I would probably do the inside first. It's nice and simple, which is just 2x. Yeah. Plus 2x. I've differentiated the inside. Now I can do the outside, which means power comes out the front, and then the power reduces by 1. So you can see where the single x, which Samina was talking about, comes from. Okay. Before I move on, that's just the top. That's just f dash, the numerator. I have to do the denominator as well, but that's just f, the whole lot. Okay. Okay, great. That looks a bit awkward, doesn't it? Let's tidy this up a little bit. This 1, nothing much happens to that. Here, the 2.5 cancel. Cancel, cancel. So you're just going to be left with your x, but I'm writing that on top because that minus a half means that square root's going to come back down to the bottom. Okay, like so. Alright, what do I have on my denominator? That hasn't really changed around very much. I'll put it back in radical form, because that's what those things are called. Alright, now what? What can you see? What kinds of things can we do to this to make it better? Because it's still a bit of a mess right now. Any suggestions? Part of the problem is just there's fractions on fractions flying around, aren't there? Okay. So what can I do to sort of fix up the fraction that's on the top? What would you do? Is anyone brave enough to give a clear answer, or are we just gonna? I think it's a fraction. The easiest way to get rid of the denominator is just to multiply through by whatever the denominator is, right? Okay, so let's multiply through by the square root of x squared plus a squared. This is 1, so it's just going to become that. On that second term on the numerator, the denominator disappears. That's why we multiplied through by that. Okay. Multiply the top, so we should do the bottom as well. Now, some of you might think, oh, cool, I have an x squared plus a squared, the square root there. I've got the square root there. That'll simplify out. But hold on there for a second. It might not necessarily be the most useful thing for you, okay? Especially noting that, see how my numerator is? Look at how simple it's become. And look at its relation to the denominator I already have. So rather than actually simplifying my set, I'm not going to do that. I'm just going to leave them factorized like so. Oops, read the other way. Sorry. Okay, now what? I can just cancel, can't I? There we go, done. So all I have on the top is just a 1 over x squared plus a squared. That's kind of neat. That's nice. It looked really awful to start with. Okay. So remember I said this is kind of differentiate and then hence integrate. It's one of those kinds of questions, right? So if the derivative of this is this, what integral statement can I form on the basis of this working? If I differentiate this and I land here, I ought to be able to go the other way. If I integrate this, I ought to land here. Yeah? So I'm going to write down the integral of 1 on x squared plus a squared with respect to x. Okay? It's a non-logarithmic integrand. Okay? You integrate it and you'll get this. X plus the square root of. Okay. A little bit messy, but it works. It's not too bad. Okay. Right, now just one last thing before I leave off this. Like I said, this is on the table of standard integrals. But there's another one which is very similar. Okay? In fact, the only difference is there's a minus there. Okay, now, let's see how your algebra is. Okay? Suppose this was a minus. So there'd be minus here. What difference would that make if I trace my working all the way back up to the start? What difference would you expect? Now let me pose you another question to help you answer that if your brain's still churning. Just silently in your head, answer this question. How much did the a squared, more specifically the plus a squared, how much did it factor into our working as we differentiated? How much did it factor in? And the answer is, it hardly contributed anything, did it? Because when you were doing this part here, you know, the a was, when you differentiated, it was just a constant, so it vanished, right? So you didn't even have it as like something you have to multiply by. Really just kind of sat around and did nothing and floated all the way through. So if the plus a squared did that, the minus a squared will do that as well. Okay? The sign actually is not going to have any effect on this. It's just that that's the number that you use. So if I have a plus here, that's what I end up with. If I have a minus, I'll end up with a minus here. That's all. Now they write that as two separate integrals on your table of standard integrals, but that's really what it is. If you have a plus minus here, you've got a plus minus there. Minus to minus, plus to plus.